Hello, General Biology, and welcome to the second screencast in the Chapter 2, Section 2.2 series of screencasts. And we were talking about the properties of water, and in the last screencast we learned that water is a polar molecule, and because of that polarity, it can have cohesive and adhesive properties to it. So now we're going to consider that because when we think about living systems are surrounded most of the time in water. Our cells have water in them and we're surrounded in water. And because of those properties, we can get solutions and suspensions that also form. So let's talk about solutions and suspensions. One of the things we have to kind of write down and remember is that water's not always going to be pure, and it's often found as a part of something else, a part of a mixture. So we need to familiarize ourselves with the term mixture. So let's take a look at our textbook definition. A mixture is a material composed of two or more elements or compounds that are physically mixed together but not chemically combined. One of the easiest examples of this is salt and pepper. If we were to put salt and pepper together, Mrs. Saunders would sneeze over the pepper. She always sneezes with pepper. But if we were to put salt and pepper together, they would form a mixture. They wouldn't join together where you couldn't see the salt and you couldn't see the pepper, right? If you wanted to, and you had nothing else to do, you could separate the salt crystals from the pepper flakes because it's a mixture. They do not chemically combine together. So I'm going to show you a little demonstration in class of a mixture that I think will bring that home. But a mixture you need to remember is that they do not chemically combine. That's the key things. So living things are in part composed of mixtures that involve water. So we've got a lot of different mixtures that are going on where things just don't chemically combine, but they're floating around. We're going to see that DNA, which is a chemical molecule, is going to be part of that mixture. We're going to see other things, chemical compounds like carbon dioxide that is going to be floating around. Again, a compound. It doesn't dissolve. It's going to be in there. Oxygen as well will be another one of those things that we're going to find floating around. In a later chapter, we're going to talk about compounds that we call them electron carriers, NADH and NADPH. And there's more, but I'm just going to mention those two so that you say, oh, I heard about them before. They're electron carriers, and they're a mixture. They form a mixture within the cells. So we have two types of mixtures that can be made with water, and they are solutions and suspensions. And we're going to talk about those in a little bit more detail in the next slide or two. So let's go back to that salt. We all swam in the ocean. I don't like to swim in the ocean, but I did get my feet wet in the ocean. So we talked about sodium chloride. Well, what happens when you add that to water? Well, remember, sodium loses an electron and it becomes positively charged. Chlorine gains an electron and it becomes negatively charged. And what do we know about that compound of water, that Mickey Mouse compound, that we have a positive side and a negative side? So considering that, can you kind of see what's going to happen? The chlorine is going to be attracted to the positive side of the water molecule, and the sodium is going to be attracted to the negative side of that water molecule. And when it does, it's literally going to be pulled apart like you see here, where there's going to be water molecules that are going to be holding the chlorine and water molecules that are going to be holding the sodium, and they're going to be evenly, at some point, evenly distributed throughout, and this is a solution. This is forming a solution. We're not changing the chemical composition at all, but we are having the chlorine and the sodium being held by the water molecules that are in that container, that beaker. So the ions gradually become dispersed. Remember, these are called ions now, and in the water, and they form a type of mixture that is called a solution. And we'll get water molecules holding as much as the sodium ions and the chlorine ions as they possibly can. If we run out of water molecules to hold them, then the excess will settle on the bottom, and that'll be called a saturated solution. My husband used to be a coffee drinker, and I used to tease him because he liked a little bit of coffee with his sugar. And you could always see when you went to get the cup that there was still sugar sitting on the bottom, because he would put so much in that the water within the coffee could no longer hold the sugar, and it was saturated. It couldn't hold anymore. Okay, but a regular solution is where all of the molecules hold it, and it's equally dispersed in the water, and it forms a solution with no overall chemical change taking place. So when we think of solutions, the components of a solution are evenly distributed throughout the solution, and we need to learn two terms. And if you're anything like me, these two terms can be easily confused. So when we look at the table salt that we were working with, we're going to call that the solute. And the solute is the substance that is dissolved. Okay, so what we want to dissolve, that's the solute. So if I was making Kool-Aid, Kool-Aid would be the solute. It's what I want to dissolve. Or lemonade. Lemonade would be the solute. The water is called the solvent. And water is a universal solvent. Water usually does most of the dissolving, and that's what solvent comes from. And this is the substance in which the solute dissolves. So can you think of any other examples of solutions that you might make in your own kitchen? I just mentioned two, Kool-Aid and lemonade. Can you think of anything else? Okay. The way that solutions work is because of water's polarity. It gives the ability to dissolve both the ionic compounds and the polar molecules. Okay, so that polarity allows that to happen. And water easily, as we saw, is going to dissolve in salts and sugars, minerals and gases, and even some solvents such as alcohol. When given an amount of water that has dissolved all the solute it can, then that solution is said to be saturated, when it cannot dissolve anymore. Now suspensions, they're a little bit different. Suspensions happen because materials do not dissolve when they're placed in water, but instead they're separated into pieces, and these pieces kind of suspend and are held in there, and these are called suspensions. Okay, some of the most important biological fluids are both solutions and suspensions, and the biggest example is blood. Blood is made mostly of water. It does contain many dissolved compounds like carbon dioxide and oxygen that happens to be in there, but it also contains undissolved particles like platelets and oh, my mind just went blank. Platelets and other little clotting factors that happen to be inside of the blood. So let's think about your kitchen again. What types of suspensions are you familiar with around your home? Okay, the one I think of right away is Italian dressing. It has all of those spices that is suspended within that. If you have a minute or two, Google, there was a drink. There was a drink called Orbitz. I think you could Google it and see some pictures. And it was like a really thick liquid, and it had floating flavor beads inside of it, so that when you drank it, the beads would burst, and that's what you would get the flavor from. Well, they had to stop selling it because bacteria and mold could form around the flavor beads. But you might be familiar with like the little beads that they put in the Purell, the moisturizing beads. Again, they're making a suspension with that, and that's a suspension. And your blood is a suspension, and it's one of the most important suspensions. Cells, we're going to talk about the cytoplasm being a special type of suspension as well. So these are suspensions that are essential to living things. Okay, and another characteristic or property of water is that it can determine the pH of a solution. And pH tells us whether something is going to be an acid or a base. So that is a reference to pH, and we're gonna talk about the characteristics of acids and bases and how water defines that. So, I'm seeing we're at 12 minutes, so I don't want to start this and end it. So I'm going to stop this one. This one's going to be a little bit short, and we'll start acids and bases in the next screencast. See you in a few minutes.